Hi friends, I'm Dr. Rendra Patil. Today we'll discuss about the anaerobic treatment of wastewater. Before discussing this particular topic, we'll see the wastewater treatment process for municipal wastewater. As you know, municipal wastewater contains inorganic as well as organic matter. So its removal is very important before disposing this wastewater into any water body. So this figure shows the several units utilized for the treatment of wastewater. First unit is a core skin, which is necessary for the removal of floating matter from the wastewater. Second unit is grid chamber, which is essential for the removal of inorganic particles such as sand and silt. So effluent from the grid chamber, after removing the grit from it, it is taken to the primary sedimentation tank for the removal of suspended organic matter. So suspended organic matter settles at the bottom of the primary sedimentation tank. Further, the effluent from the primary sedimentation tank is taken for the secondary treatment, which is you already know it is a biological treatment. So there are two methods by which treatment is given to the wastewater. So one is attached growth system and one is a suspended growth system. So this figure shows the activated sludge process, which is a suspended growth system in which there is a aeration tank as well as secondary sedimentation tank. So in aeration tank, microorganisms utilize organic matter as a source of energy and a source of carbon. So in this process, they grow in number in aeration tank and converts organic matter into stable form. So whatever quantity of biomass or sludge is produced in aeration tank is separated in secondary sedimentation tank. So sludge settles at the bottom of the secondary sedimentation tank, and effluent from secondary sedimentation tank is taken for the disposal. That effluent, either it is used for agriculture purpose or landscape reuse. So it is very important to note down the important point, that is what to do about the sludge settle at the bottom of primary sedimentation tank and secondary sedimentation tank, how it can be treated. So it is generally treated using anaerobic treatment method. So today we'll discuss anaerobic treatment method of wastewater treatment. So in anaerobic treatment of wastewater, anaerobic microorganisms in absence of oxygen converts organic matter into biogas, that is methane and carbon dioxide. So most of the organic carbon is converted into biogas and little sludge is produced, that is little microorganisms are produced in anaerobic treatment. So you might be knowing that in aerobic system that works in presence of oxygen, maximum fraction of organic matter, almost 60 to 80% fraction of 60 to 80% of organic matter is converted into biomass. However, in case of anaerobic system, less than 5% organic matter, 5% of organic matter is converted into biomass or microorganisms. So what are the processes involved in anaerobic degradation of organic matter? So there are four steps or processes. One is hydrolysis, second one is acidogenesis, third one is acetogenesis, and fourth one is methanogenesis. So in hydrolysis process, there will be transformation of higher molecular mass compounds into compounds suitable for use as energy and carbon source. So in hydrolysis process, complex organic matters are converted into simpler organic compounds so that these simpler compounds can be utilized easily as a source of energy and carbon by microorganisms. So further, these simpler compounds are converted into amino acids, sugars, fatty acids, or intermediate products such as propionate and butyrate in acidogenesis process. So acidogenesis is the process where there will be bacterial conversion of the hydrolyzed compounds into identifiable lower molecular mass intermediate compounds. So further, these amino acids, sugars, fatty acids, as well as propionate and butyrate, these all are converted into acetate hydrogen and carbon dioxide in acetogenesis process. So in acetogenesis process, lower chain volatile fatty acids produced during acetogenesis are utilized by acetogens to produce hydrogen and acetate. Further, acetate and hydrogen as well as carbon dioxide produced during acetogenesis process, these compounds are converted to methane and carbon dioxide in methanegenesis process. So methanegenesis is the process wherein there will be bacterial conversion of the hydrogen and acetate into final end products such as methane and carbon dioxide. So what are the factors which really affect the anaerobic degradation of organic matter? So first point is time. Why it is important? It is important because of the history of microorganisms. If microorganisms are not exposed to organic matter present in wastewater in the past, it will take time. The microorganism will take time to acclimatize with the given food. Now, if these microorganisms are exposed to organic matter in the past, the acclimatization time will be less and treatment process will start within a short time. So time is very important as far as anaerobic degradation of organic matter is concerned. Second point is pH, acidity and alkalinity. So the optimum pH range for methanogenesis is 6.6, 7.6. However, because of the formation of amino acids, fatty acids during acetogenesis process, there will be drop in pH of the wastewater. So methanogens will not work or for the conversion of acetate and hydrogen and carbon dioxide to methane, it is necessary to maintain the pH around 6.6 and 6.6 to 7.6. And because of the formation of these fatty acids, amino acids, there will be drop in pH. So it is necessary to maintain the pH of the wastewater. So buffering agents like sodium bicarbonate, calcium bicarbonate need to be added regularly to maintain the pH in desired range. Furthermore, it is also necessary to maintain the temperature in anaerobic treatment. Anaerobic processes mostly operate well at mesobolic range, that is 30 degrees Celsius to 40 degrees Celsius. However, methanogenesis can occur at temperatures as low as 20 degrees Celsius to 15 degrees Celsius. Furthermore, the presence of metals such as copper, nickel, lead, chrome, etc. may create problems to microorganisms. So it is necessary. So obviously, the presence of these metals will induce toxicity in anaerobic reactors. So anaerobic treatment process, there are several applications for the industries. So industries such as slaughterhouses and cold storage facilities, breweries, leather factories, dairies, sugar refineries, potato processing, wine production, all these industries utilize anaerobic treatment process for the treatment of their wastewater.